You'll have to bear with me here. I made an entire video and then the computer ate it. So let's figure out a couple things. All right, one, alpha is right here, which is where we left off. We had alpha is equal to 0.05. And then I'm going to take the time to find the degrees of freedom right now. Now remember, degrees of freedom is equal to the row total minus 1 times the column total minus 1, which in our case is equal to rows, there's 2 of them, so 2 take away 1. And then columns, there's 1, 2, 3, 4, 5 of them. So that's 5 take away 1. So multiply those two, it's your degrees of freedom. We'll just need it for later, so you might as well. All right, now the test statistic, which is what we hadn't found before we left, it's going to be equal to the sum of this whole table over here. Now, what is this table? Well, the test statistic is this formula right here, and you can see you need the observed minus the expected squared divided by the expected. So I'm making this table to kind of help myself out a bit. So I take the observed, which was 302, minus the expected, which was 275. I put those in parentheses and I square them, and then I divide it by the 275. And then the beautiful thing is, because of the way I've made these tables one right below the other, I can just drag over and then drag down, and everything gets automatically filled out. Neat, huh? All right, now how does that help me with the test statistic? Well, the test statistic is the sum of all of these values. So you say equals sum, and you can just highlight if you want. Sum of all these values, enter. And it finds it at 37. Now, step 4 is both, you can do it the classical method and the p-value method. Of course, we will do both. So the classical method, you have to find the critical value. Now the critical value is equal to the chi-square.inv.rt of that 0.05, comma, that degrees of freedom. Now you don't have to subtract 1. It's already taken care of in that formula, so it's just 4. If you have old Excel, it would just be chi-inverse of those two values, 0.05, comma 4. Remember, everything in chapter 12, all of them, they're all right-tailed, every last one of them. Because you square things to make them positive, then that's all you're interested in is the positive part. Now the p-value would be equal to chi-squared.dist.rt x comma degrees of freedom, x being their test statistic, which would be 37, and the degrees of freedom was in cell J7, so it was 4. If you have older Excel, it would just be chi-dist. Right? Old Excel works great for right-tailed like these are. It doesn't work well for the other ones. All right, now how would step 5 work? Well, we would reject the null hypothesis because our test statistic of 37 is greater than our critical value of 9.49. Or you can think of it as the p-value is 0, which is really low at less than 0.05. Now, let me write up the step 6, and then let's go see how to do this in StatCrunch as well. Actually, you know what? Let's double check ourselves in StatCrunch first. Why not? Okay, so we want StatCrunch, which is right here. And I'm going to have to copy and paste those values in, so hold on. All I'm really interested in is this table right here. So I copy, and I'm going to go to StatCrunch, which is over here. And I'll just mosey on over here. Paste. And if I want to change this, I can say like yes, no instead of variable 14. That's, variable 14 is not very useful. So I could say yes, no. All right, wonderful. Now, when you run the test, you go stat, tables, there it is, contingency, summary, because all the information is given to us. All right, so where are your data? It's in less than high school, junior college, bachelor's, and graduate. Your row labels are in the yes, no thing that I made up. Next. I would like it to give me the expected count, say, and the chi-square. Calculate. There we go. Beautiful. And notice it actually gives you the values for the expectation right below. So 302 is what we observed. 275.4 is what we expected. Let me copy and paste. So you can see 275.4, that's exactly what we came up with there. And then you can see the p-value is less than 0.001, just like we said, and the test statistic is 37. So let me write up step 6. There we go. We've proven that at least one proportion is different, i.e. somebody thinks differently about whether or not equal opportunity education in the U.S.